All right, so here's another example. Similar, instead of 1 over x, it's 1 over x squared, right? So, but we're still approaching 0 from the left and 0 from the right. And I didn't mention this in the last one, but it's true of the last one and of this one. If I plug in 0, then I get an undefined value, right? So this is a situation where we can't just input 0. We have to use a limit to kind of evaluate what happens, because we can't just plug in 0. So what I'm going to do is same thing as last time. If I'm approaching 0 from the left, I'm going to go negative 0.1, negative 0.01, right? Just getting real close to 0 from the negative side. So these numbers are going to get smaller and smaller and smaller, right? Okay, same thing on this side except for positive, 0.1, 0.01, and so forth and so on, right? Okay, all right, and so if I plug in negative 0.1 here and I square it, what's going to happen is I'm going to get positive 0.01. That's what happens when you square 0.1, is you get 0.01. Okay, if you square a tenth, you get 100th, right? And that's basically what happens here. And if I do 1 over 100th, I get 100, right? Positive. So same thing here. We'll put negative 0.01 squared. All right, if I square 100th, then we get 10,000th, 1/10,000th, right? Okay, and that's going to become 10,000 if we divide 1 divided by, oops, I messed up here. Sorry, it should be 1 over 1/10,000th, which is 0.0001. So that becomes 10,000. Okay, and then so forth and so on. So this will be, so notice this time if we square it, we're adding 2 zeros every time, right? So this is going to be, the next one's going to be 1 millionth. Okay. All right, and then the next one will be 100 million. Okay, and so forth and so on, right? And so what happens is this time we're getting larger and larger in the positive direction, right? And so we're approaching positive infinity. Okay, so even though we're approaching 0 from the left, because we're squaring the denominator, we're turning these negative values into positive values, right? And then when we do 1 divided, those and every time we square a decimal, we're going to get a smaller number, right? If we square a number that's a fraction, a proper fraction, we're going to get a smaller number. And so we're getting smaller numbers down here. So when we do 1 divided by even smaller number, we get even bigger numbers, right? And so this is actually increasing towards infinity even faster than the last one we saw, okay? So positive infinity is the limit as x approaches 0 from the left of 1 over x squared. Okay, now let's see from the right. We're going to see pretty much the exact same thing, right? If I square 0.1, I get the same thing as if I squared negative 0.1, right? So this and this are the same, because when you square a number, you get a positive, right? And so this is going to be 100 here. When I do 0.01 squared, I'm going to get 1 over 1/10,000th, which will give me 10,000, and so forth, right? So it's actually a mirror image of what's happening here, right? It's going to keep adding 2 zeros every time. Every time I add 1 0 in front here, I'm going to add 1 0 behind here. Okay, and so forth and so on. So this is going to go towards positive infinity as well. All right, and so now in this case, the limit from the left is the same as the limit from the right. And so since they're the same, since they both equal positive infinity, that means the limit, the overall limit, is going to also equal positive infinity. Okay? All right, so that's how we do limits towards infinity. And by the way, the graph, let me go back to the last one. I don't have the work here anymore, but just to show you, just to confirm with the graph of this function 1 over x, and you've probably seen this before in Algebra 2 or so it looks like this. Okay, and there's an invisible boundary here at 0. So as it gets closer and closer to 0, it can never be 0, right? But as it gets closer and closer to 0 from the right, it goes up towards positive infinity, and as it gets closer and closer to 0 from the left, it goes down towards negative infinity. Okay, and so that's what this function looks like, 1 over x. Let me just label it here. Right, now this function that we just looked at, 1 over x squared, it looks similar on the right. It's a little steeper, right, because it goes up faster. But on the left, it actually is a reflection across the y-axis, so it actually also goes up like that, okay? So we still have that invisible boundary there where it can't be 0, but on either side it goes up forever, right? It goes up forever on the right, goes up forever on the left. And so that's what this function looks like. Okay, because no, this can never be negative, right? If I square a number, no matter what I put in here, if I have a positive 1 over something squared, it's always going to be positive. And so that's why there's nothing down in the below the x-axis.